So I'm Lars Thalmann. I am the development manager for Replication and Backup. And we also have Kindahl, who is the lead application developer. So if you have questions in Replication after this talk or at any time, you can just grab us in the conference. And we also have Jack Bell, who is working with Backup and Replication. So you can please try to catch us in the conference and ask questions and so on. We're interested to know what you think about replication. So this session will be about new features in MySQL Replication, and mainly in the new 5.5 release that is now in beta stage. So let's start. The topics for this session is, well, first just a brief review of what we did in MySQL 5.1 regarding replication features. Then what features we had in the 5.5.2 release and the 5.5.3 release. And then some information about the ongoing projects we have. And first of all, how many people here are using 5.1? Can you up with that? How many people are using 5.0 or older? Okay. So there are quite a few changes in 5.1 in replication. So I'm curious to know if you want to upgrade and what's stopping you and so on. So and if you have problems in replication, it can be a good thing to upgrade so you get the latest stuff. 5.1 has been around since November 2008, so it's getting quite old now. So what was new in 5.1? We introduced row-based replication. So before that, everything was replicated. Just you took the queries, the statements, and those were being replicated, but then we introduced this row-based replication. And we have this different binlog formats, so you can specify if you want row format or if you want statements to be shipped. We introduced MySQL cluster replication, so you can replicate between different MySQL clusters. We introduced save slave skipping. So if you skip events on the slave, now we skip complete transactions. So it's less likely that you get problems if you're skipping things. We have safe replication of unsafe statements, so non-deterministic statements. There are a few statements that have that can generate different results depending on the context or when you execute them. And what we introduced in 5.1, if you use mixed mode, is that it automatically switches to row-based format. So you actually get the data that should be stored. So the master and the slave will have exactly the same information. And for statement format, we introduce warnings for these statements. So if you still use statement format in 5.1, you will get the warning saying that these statements are not, there is a risk that they will give a different result on the slave. So for new users who use 5.1, we recommend that you use the mixed format. If you want to have something that is totally backwards compatible, then you can use the statement format, because then it's like 5.0 and over. But if you are a new user and you're just starting to use MySQL, we recommend that you use the mixed format. By default, we have statement is still the default, just to always be backwards compatible and not to break any application for people who upgrade. We also introduced replication of event definitions. So if you create an event on the master, the definition of this event is replicated over the slave. But if you would execute events also on the slave, we could get double effect, because the effect of the events on the master are replicated over, and if you would execute events on the slave, you would get effect again from these events. So the way we did it is that we replicate over the event definitions to the slave, but we keep them disabled on the slave. So you get the effect from the master through replication, and if you want events to be enabled also on the slave, you need to do it by some kind of procedure. We deprecate configuration options. Before 5.1 you could set all the different change master variables. You could set them in the mysql file, but it caused confusion because if you restart the server, it's actually not reading the configuration file, it's reading the master info file. So it's a bit confusion, caused a bit of confusion sometimes for people. So we removed this. So you need to use the change master in file. And we fixed over 250 replication bugs when we released 5.1. Most of them are fixed in 5.0 as well, but some of them are only fixed in later versions. Some questions about this? Okay. Feel free to interrupt with questions anytime when we can make it a bit interactive. So, what did we do for 5.5.2? Well, we introduced semi-synchronous replication. So, in using semi-synchronous replication, you let the master wait until the slave has persisted events. So, the user who's executing the transactions don't get a response from the commit until it actually exists on the slave. How many people here have actually tried out semi-synchronous replication? No one. Okay. There are. I hear some people are experimenting with it, but it would be good to get more attention. Yes.
What happened to 5.4?
Is this my question? Is I'm going to answer this?
You had 5.1, now you have 5.5.
Yeah.
You jumped over something.
Yeah. Yeah. What happened to that?
The dolphin has to jump over some things, so
it's in the same repository as 5.3 and 5.2.
It's the black hole release engine.
There was some discussion about the version numbers, but in fact, the 5.5 release is kind of the 5.4 release. So I think it's just that the numbering changed for some reason. I don't really know. We had a 6.0 release for a while as well that we were working on, and that had some code that we could not give out because it was not stable enough. So we actually took and backported a lot of things from 6.0, and then we created this 5.5 release. So the 5.5 release is the 5.4 release plus a lot of stuff from the 6.0 release.
Well, why is it semi-synchronous? It sounds like it's fully synchronous.
Yeah, I'm going through that on the slide, and I'll get back to that question.
5.5.2 is just based on
5.5.2 and 5.5.3 are GitHub releases. They are development releases. Right, so semi-synchronous replication we implemented, and I will go through this on some slides so that you see a little bit more of the details about these things. We implement a slave fsync tuning so that you can say how often you want the info files of the slave to be synced to disk. So it's quite hard to make. If the slave crashes, if you do kill -9 on the slave, it is if you set these options correctly, it's quite hard to not to lose events. So this makes the slave much more safe for crashes. Then we implemented automatic relay log recovery so that the slave will automatically refetch the relay log if when it's restarted. So if you restart the slave, it will refetch the relay log. So if you have any corruptions, if the slave has crashed for some reason, and there is a risk of any corruptions in the relay log, it will refetch it. We have the replication heartbeat. So if the master is not being used for anything, then we send like a fake event over to the slave just to indicate that the master is still alive. And that makes that the slave is always aware now that the master is alive. So you can have much more safe monitoring of replication, and it might actually be certain that the master is alive.
So what does this mean? So when you do a show this status, because the seconds since last update, will that be like 1 second, 2 seconds out of it? How will this affect the monitoring part?
So is the question of how often we send a heartbeat, or?
No, the question is how will that affect the monitoring?
The monitoring is that if you check the slave, so if the master dies, then the slave will recognize that it doesn't get any heartbeat anymore. So if you check the slave status, you see that now something has happened because the master is no longer there. Before, it could be that the master was idle, you didn't do anything with the master, and so everything was working, it was just that it didn't have any traffic. But now we send this all the time so that the slave knows that the master is existing. Yes?
Does this give us a more precise seconds behind master for monitoring?
It's that's also a project that the current code doesn't really give this now, but this is the foundation for getting a better seconds behind master as well. So the current code, we haven't improved that yet. Right, we have show relay logs, so it's just like show binlog events. You can now show the events of the relay log in SQL. So it's just something that makes it a little bit more convenient to see the relay log events. There is the per server replication filtering. So you can say that you don't want events from particular masters. So usually, if you replicate in a circle, if an event comes back to the server that created it to start with, then it's automatically deleted and it's not executed. But with this functionality, you can also say that I don't want to exclude my own events only, I also want to exclude some other servers' events. So I will go through the details of each.
Isn't there already an option to discard same server events?
Yes. The same server events per default are discarded. So if you get it from the same server that created it, it is automatically discarded, and there's an option to turn that off. But with this one, you can also do it for other servers. So there's two main uses for this, and it's in circular replication and it's in cluster replication that people use it. And I'm sure that there will probably be other uses for it that you come up with. So semi-synchronous replication, which was developed by Google, it's two different plugins. It's one for the master and one for the slave. And replication works in the normal way. It sends over the replication events. But when they have been received by the slave sends an acknowledgement back to the master. And when the master receives this acknowledgement, then it returns the commit to the application. So this is a way to make it sure that when you get the commit in your application, at the time you get the commit at the application, then you know that it's also on the other side. So the MySQL application is asynchronous. So if the master fails, there could be some transactions left in the master that didn't go yet to the slave. So semi-synchronous replication ensures this redundancy because the application, when it gets commit, it knows that it's also on the slave. And fully synchronous replication would include more things. So in fully synchronous replication, you need to use something like two-phase commit or some other protocol to ensure this. And in synchronous replication, In this case, for instance, you can still execute, it's still executed on the master, and if the slave fails, then it's still executed on the master. So even if you don't get it to the slave, it still exists on the master. You don't get the commit back, but you executed it on the master. So there is a small window where you could have it only on the master. What it ensures is that when you get the response from the commit, then you know that it has been replicated to the slave. But there are some failure scenarios where you still have it only on the master in case the slave has failed. So what did Google do? They did at least one slave receives the events before the commit returns to the user. So the master waits for the acknowledgement using a timeout. So you can set this timeout, how long time you want to wait for this commit, for this acknowledgement to happen. And if it waits longer, it will assume that it went good. So it automatically disables this semi-sync on timeout. And then it re-enables the semi-sync when the slave catches up. And what we did was that we merged this into 5.5 and we defined the interfaces and implemented this as plugins. So I think this is extremely interesting to see how many people would like to use this and if it suits your needs and so on. So if you have some time over, please go ahead and try this and see what you think of it. Yeah.
So, are there storage engines that are not supported?
No, this is on a higher level, so it's actually should not be dependent on the storage engine.
Right. So I saw this merged from MySQL 5.5 removed dependency on the other thing. So
Yes. There was the code from start was had code changes in InnoDB, but we made it abstract, so it doesn't care about what storage engine you use. So that was yes.
What's the performance, the effective performance overhead of this? Have you guys done much testing on that yet?
No. The performance overhead is the acknowledgement sent back, and there is very little processing on the master. So.
But I'm just curious, because you know, like, it's pretty easy to benchmark on low-end equipment to get 10,000 updates per second in pipeline. So I'm just curious if you have any sense of what the overhead is in the benchmarks, like 5%, 10%.
It would have to depend on the latency of the slave, right?
Exactly.
Yes. It's mainly dependent on the latency. But Mats, I don't know, do you know if we did any benchmarking on Semi-sync?
No, we haven't done any benchmarking. But it's basically just waiting for the site overhead. The actual code executed is minor, it's almost minor. So it depends on the network latency basically on here.
So won't the master be waiting for some acknowledgement from any slave before the master proceeds to send the one?
Yeah.
So you could potentially have some.
Yeah, you can have
Up to the timeout.
It has to be written to the relay on one slave, then you get a reply. So that's
So we should notice that there is many people have a problem that the slave is lagging behind because when it applies stuff on the slave, that can take some time, especially since it's single-threaded execution on the slave. But in this case, the only thing that the slave acknowledges is that it has received it and stored it in the relay log. So it's not waiting for it to be applied on the slave. So it goes quicker than that.
In your continuous transfer, you're not waiting for each individual act, is that right? You're just going to jam stuff there and then keep act back.
Right. We're sending the binlog over, and just the commit holds on that connection, So that particular commit will have to wait for the acknowledgement. But the other transactions the other threads can execute without any problem. Yes. Yes?
Does it work with row-based replication? It sounds like this is waiting for each transaction to be synchronized with the row-based replication.
Yeah, this works with the row-based replication as well.
If you're using more than one slave server, and then still will commit back when the first slave will commit with this one, it means that we don't really know which of the slaves actually have it and which doesn't, right?
Right. It's one slave.
So to be clear, if the knowledge says when you get to relay log or when the fault disaster is committed on the slave?
No. The transaction is not committed on the slave. The transaction is only stored in the relay log. That is what is acknowledging.
Oh, okay. Thank you.
Yes, in the back.
If you have more than one slave, multiple slaves, and if any one of these slaves returns acknowledgement and the master commits, and the other slaves fail, and then over time, when all your slaves are still out of sync, right?
Okay, so you have multiple slaves. One slave is failing, another one is acknowledging it.
In the next transaction, other slaves acknowledge, but this one failed.
Okay. So you mean that they sort of toggle and right, but when the first slave comes up again, then it should start on the position that it was stopping on. So it will get the first transaction as well. Because otherwise you do some kind of bad recovery on the slave. So then it will have that, and then the next one, when that recovers, it should get also the ones it's missing from the master. So I don't really see any problem with that.
Unless the transaction just failed. It didn't break, it just failed. It's not there for some reason.
If the transaction fails on the slave, then, well, if the transaction fails on the slave, you get an error message. And then if you go in and you skip that part of the binary log, which it seems that many people are doing, just skipping stuff, and it kind of works, but that's a very scary, it's very scary to just skip things. So, well, it depends on your data. Sometimes you have data that it doesn't matter that you skip some things. On the other hand, if you have data that it doesn't matter that you skip them, maybe you don't care that the slaves are a little bit different either.
If something matters that it's straight into the relay log, does it therefore work if you only have slave IO running, not slave SQL, the slave SQL through running? So you're only running the binary log, so does that?
This should work even if you have only the IO thread working, yes. Tobias?
So I was wondering, if I commit something on master, it's waiting for the slave to act that commit. So I'll set it off to relay log. On the way back to the act packet, the master fails. I bring both servers back up. Now the slave could actually have more stuff committed than my master?
No, I think it's committed on the master first, right? It's committed on the master first, so it's not blocking the commits on the master, it's blocking the return of the commit to the user.
So it actually commits it internally?
Yes.
Okay.
Yep.
Did I understand you correctly to say that when the slave is reading the single-threaded binary log from the master, if there's one particular, if the, how does this work? When you get the, let me see if I can phrase my question. If it's waiting for an acknowledgement, never mind. Actually, I can't even phrase my question. So.
Okay. I think I need to move on a little bit. So this is how you set it up. It's very easy. Just install the plugin, and then you set some variables, and you do this on the master, and you do it on the slave, and then you start the slave. So install plugins, set some variables, and then you go. There is also some variables that you can use to check the status. So on the master and the slave. So if you try this out, since there is not so many people who have actually tried this out, except internally we have tested it quite a bit, but please feel free to send me an email just saying that I tested this, it doesn't work, it works. Or, I think it works, but it's more like, does it fit your need? Does it solve your needs? That's what I'm interested in. And if it doesn't solve your need, what are you missing? Is it something you can do too in a later version of this? Yeah.
So, let me go back to my question. So if you get this wait timed out situation on the master, then we look at these variables, and what do we do with that information to determine that you got to wait or not? Is that useful in diagnosing the situation?
You can check these variables and you see how many transactions have been how many have you got acknowledgement on and how many did you not get acknowledgement on, and you can use that to decide if things are working as you expect for your scenario or not. Let me move on a little bit. Slave fsync tuning. There is 3 new variables. The first one is that if you set it to some value higher than 0, you would synchronize the relay log info to this after that many transactions. So generally, you want to set it to 1, so that you would sync after every transaction, you sync this relay log info, so the relay log info correctly has the information about how much it has received from the master. Since we want things to be exactly as before for the people who upgrade, we have this, the default is to have it disabled. We have one also for the master info, and for most situations you do not need to synchronize this. And if you set it to something that is bigger than 0, then it will flush this after that many transactions. There is also a flag for syncing the relay log, but usually you don't need to do that either. So the one that you set to 1 is this relay log info. Yes?
Does setting that to 1 make you crash safe in replication, or nearly?
Nearly. There's still a small window. So actually, I don't know if I said it the wrong way. This is what has been applied on the slave. So there is a small window then between you actually applied it and you update this file. So there is a little bit of window where you still could have a problem. But we run internal tests, and we had one customer doing tests on this as well. So the first test we did, and test for the customer, we couldn't notice this period because it was so small. And then there was some other customer that also tried this out, and they found some situations where you actually can still have a problem. But it reduces this risk immensely. It's just a very, very small time when you can have this failure. Yeah.
So the application that failed, what kind of an application was that? Was there something?
No, it's the slave server that crashes. So for some reason the slave server crashes.
Did they have more than one slave and only one crashes? Or?
No, they were a company having a lot of servers. So this is something that the time you get corruption on the slave is not very often. It's extremely seldom.
Well,
and then if you add this as well, then it becomes even less. So you need to have a testing scenario where you can actually test this to see. Yeah.
So you said that you can, on the next slide I think you were saying that you can enable syncing on the master info, but you usually don't need to do that. And you can enable syncing on the relay, but usually don't need to do the relay. So what's the use case? In what cases one need to enable syncing?
Yes, that's good. So it depends on if you want to be. I don't have a good answer on it. I think it depends on. You have a good answer?
Yeah, it basically depends on. It's a trade-off. If you are setting this and it doesn't sync, then you trust the file system to synchronize.
No, well, if you don't sync a relay log, then you lose part of the relay log. You just fetch the data again from the master.
Yes, yes.
So it's safe not to sync the relay log.
So the relay log, we have this this one, the automatic recovery, which is actually fetching the relay log again.
Yeah.
So if you set this to 1, then you don't need to have this stuff enabled. So every time, if you set this to 1, every time you restart the slave, it will refetch the relay log. So if you have any problems with it, it will refetch it. Replication heartbeat. If the master is idle, then it will send these fake events instead, the heartbeat events, so that the slave knows that the master is still alive. So there is also, earlier there were problems in that the relay log was rotating when the master was idle, because if they didn't get any events, it's assumed the master was dead, which it might not have been, and then every time it makes a new connection to the master, and it rotates the relay log. So you get a lot of these empty relay logs. And with this one, you don't have this problem anymore. And this is how you set it using change master, and then you can check the status of how things are going. This is the show relay log events. So if you start replication, and then on the slave you just do show relay log events on the file, and then you get the same kind of output as you do from show binlog events. There is a per server replication filtering. So if you have a circular setup, then if A produces an event, when it gets back to A, it will automatically be removed, and you will not execute that again on A, because that's what was the place where it was started. If you remove one server, then if you happen to have an event from A already in this circle, then that could loop forever in this circle. So the solution for this is when you create this smaller circle, because this one has failed, you at the same time you say that events from A should be ignored on, in this case, it's on server B. So when an event from A comes back to B, then it's removed. There are, so the recent 553, which came out, I think today or yesterday, something like that, have 3 more features. There is precise slave type conversions. So you can have different types on master and slave. So if you use an int and a tiny int for a column on the master and the slave respectively, then using statement-based replication, you have always just executed the statement on the slave, so it would work if you change the types. In row-based replication, we said that we are going to be more strict about this. So we say that you have to have exactly the same types on the slave and on the master. So we want to make sure that there's no problems in that people define different tables by mistake and then start replication and all of a sudden lose data and so on. So we made this, this quite strict. And what we have implemented now for 5.5 is that you can configure this if you want to have different types. So especially for cluster, and when you use cluster replication, they want to upgrade their schemas, and they want to change the type in their tables. And now you can say that we call it promotion and demotion. So promotion is if it goes into something that has a larger domain, so you don't actually lose anything. And demotion, then it goes to a smaller domain. So this is now configurable. We have individual log flushing, so you can do, when you do flush logs, you can say what logs you want to flush. So you don't flush all of the logs. We also have safe logging of mixed transaction, so you can mix InnoDB and MySQL change in the same transaction. If you're using an older version, if you're using 5.1 or anything earlier, the recommendation is that you don't do a begin commit where you have both InnoDB and MySQL in the same transaction. But in 5.5 you can actually mix them in the same transaction. There is in 5.1 there can be problems in that they can be serialized in a different order in the log. So going into a little bit more details. So if you have a create table and you have an int on the master and a tiny int on the slave, then if you use statement-based replication, this works. And it works in 5.1. And if you use row-based, then we do not support conversion. So if you have an int here, you have a tiny int here, then you will get an error saying that, well, we cannot do this insert because the type has changed. So for 5.5 we introduced a new variable, slave type conversions, and you can set this to a set of values. So if you include in the set, you include all non-lossy, then you can do conversions to types that have a larger domain. So you can do it from tiny int to int, for instance. And all lossy, then you allow yourself to lose data, because if the value is high enough, it will be truncated. So we have conversions within the integers, within the decimal numbers, within strings, binary, and so on. But you cannot convert between different domains. So between different types of integers you can do conversions, but you cannot do it from an integer to a binary, for instance. Yes?
But with lossy, you don't check for the actual value being inserted, but just for type on the master and the slave. So I mean, if you want to replicate 1 into a tiny, it still won't succeed, even if it will fit in there.
If it would fit in there, then it will be correctly, if you have this all lossy, then it will be correctly put in there. But if the number is too big for it to fit, okay, then it will be cut.
The actual value and not the data type of the master.
Yes. But
basically, when you are replicating from two columns with different types, it checks first that the column types can sit in the If you have lossy enabled, you are allowing replication. It ignores the value. It just allows replication from a larger column type to a smaller column. Then when the value comes, that is handled. If you have a conversion, then you can have a rounding basically. It's truncated. It depends on, it's using the normal built-in internal conversion in MySQL.
So actually, I don't have a setting where I can say accept a 1 from an int into a tiny, but don't accept 257 from an int into a okay. That's not
so you cannot do that. If it's too big, then it will be truncated. So this is just another slide. So then if you set it to all lossy, then you can do replication from int to tiny int. But if you say that if you don't allow any kind of conversions, then it will leave an error state. So individual log flushing, we then support that you specify what type of log you want to flush. So this is examples. You can just specify, I want to flush the error logs and the relay logs, but nothing else. And there are different types of logs that you can specify that you want to flush. Safe logging of mixed transactions. This required a bit of refactoring of the code. So how it worked before is that you get the different clients to do transactions, and they can start 2 transactions in parallel. And while they are being executing, we store them in something we call a transaction cache. And when they reach the commit point, at that time we take the transaction cache and we flush it to the binary log. So this cache is used to make sure that transactions are serialized by commit time. So when the transaction goes into the log, it's dependent on when it is committing. And so this was some problems for MyISAM, because MyISAM changes are visible immediately when the statement ends. So if you run something on MyISAM here, you see the effect right away in the data. But if we put it into this cache, it will actually not get to the bin log at that time, and will get later on it will get into bin log. So that's incorrect. So what we introduced is that we have 2 caches. We have one statement cache and one transaction cache. So we cache InnoDB changes and MyISAM changes in different caches, and we flush them to the bin log so that it will always be the exactly correct behavior. So if you're using the older version, stay away from using MyISAM and InnoDB in the same transaction. If you use 5.5, you can use them in the same transaction. And also, so this is some, so for mixed and row formats, mixing MyISAM and InnoDB is always going to be correctly serialized in the binary log. And for statement format, we have an option so that you can say that MyISAM changes should be immediately written to the binary log. But in general, we don't recommend to use this option because in statement format you can have other problems if you write it directly. Because this statement could actually, you can have 2 statements that are dependent on each other. You can have an InnoDB change that is dependent on MyISAM. And if you start to say that it should be directly bin logged, then you can get strange behavior. So this is dependent on what you want to do. And this refactoring made us close to 13 bugs, and so it made the whole code much better as well. So for the future, these are things that we are working on, and it's up for the future. We are looking at server UIDs so that you can easily analyze replication topologies that exist. We have remote backup of binary logs using the MySQL binlog tool. There's option for writing full or partial row images in row-based replication, so that you can optimize. You don't want to send the whole rows, you want to send something smaller. We're working on modular replication architecture. We're working on the replication checksums. The transactional replication information, so that you, so this is the next step. So the first step was to get this so you can synchronize the information and get it pretty safe from crashes. And this one would take it even the last step as well. We have informational events so that we can send what user and so on do the changes. Scriptable replication.
Can I interrupt just quickly? On number 6, where you're going to automatically recover from the slave crash, does that involve 2-phase commit at that point, or?
No. This is the state of the slave, so that the state is always correct, but it's still asynchronous replication. So all of these things I'm saying now are things that we are, it's kind of projects that we are thinking about working on. So there's no, I'm sure that everyone will know exactly when this is coming out, but I cannot say that. It depends a little bit. We run several projects in parallel, and the things that get done first, they are the stuff that gets into the releases. And it's also dependent on information from you, what you want to know. Information scheme for replication states, so that you can query the state instead of using show commands. And pre-allocated binlog files is to make it quicker. on the slave, or actually on the master. We're working on dtrace probes, multi-threaded slave for high performance, and there was a question about the second pair master. We are actually looking into separating this into two different measurements and increasing the precision of this. And now when we have the heart beating, we can move on this as well and making this more precise, the second pair master. And then we are working on some things when you have mixed mode and how things are filtered, should be filtered. So did we work on anything else? Did we do something more? So what is this stuff? And this stuff here. Yeah, we closed, since the last user conference, we've closed 397 bugs in replication. And 77 of these was customer support issues. And we spend about 75 to 80% of our development time on bug fixing. So, so this is of the benefit to community, and so other people are pulling this as well. And currently we have 143 open non-feature replication bugs. So in 1 year we do about double the amount that currently exists. So it's quite a rapid bug fixing for replication bugs. And currently we have 24 customer support issues that we are working. And many of these bugs some of them are still important and we need to fix them. And some of these are not that important. So there's some, this is every kind of bug that is not a feature test. So there's a lot of small test things that are wrong as well among these bugs. So this is a little bit early, but so this is the other things that are happening on the conference. We did a tutorial already. On Wednesday is the Mistress of Binary Log. On Thursday is introduction to MySQL in Clouds by Chuck. And then replication tricks and tips on Thursday. We have some information on this URL. And I will add more on this also about the new features. But the new features are, of course, described in the manual as well. So, do we have some time for questions? Yes?
Two questions. One has to do with temporary tables and how they're supported for replication, or if there's still a problem with those. And the second question would be for large transactions where you store the binlog cache to disk, and it takes a while for that to get copied over. So you can get long delays in your redo ship because one transaction took a long time.
So if I start with the second question, if you have a long-running transaction, then that is being cached and then it's flushed to disk after that time. So we're not really working on that problem. And I haven't heard of many people who are saying that they face that problem.
Yeah, so if you were trying to come up with some measurement of how it has to do with seconds behind, for example, if you wanted to set some kind of limits on how far behind you're going to allow your slave to get, then it's a problem if you have, a process where one transaction can basically throw off your distance between the primary and standby to any limit. So you can, one transaction just does lots and lots and lots of updates. And while it's copying the spill file to the binlog and then being shipped over, everything else stops.
Yes. So there's if you have a huge transaction cache on the master, then it will take some time to write to the binary log. I would assume that I don't think that's the biggest problem. The biggest problem is probably when it goes over to the slave and you're going to execute this. That is also delaying how long time it's going to take to execute this on the slave. So on the master side, we're not really working on that problem.
Yeah, so if you were trying to set some sort of concurrency limits in terms of how current your data is on the slaves, then it's difficult to do that if you have situations where any large transaction can kind of blow out your limit.
But it won't do that on the master side though, because the master
right, not on the
it
master,
doesn't block the binary log until you reach the commit point. it starts to block the binary log when you go to the commit point. Otherwise, that transaction will just lie around there on the master. Other connections will do their work, and if they commit, they get flushed over. So it's not really a problem for the delay, I would say, that you have this big thing. But let's
take it offline.
We can take it offline and discuss more details. The temporary tables, I don't know, Mats, if you can answer that.
What kind of support for temporary tables are you talking?
Well, right now what I see is that we have a temporary table that's in use, and then say the slave crashes.
Yeah.
Now the temporary table doesn't exist when it comes back up. You can't do a binlog apply on anything that came across that still uses the temporary table. So you have to rebuild your slave.
Yes. Or you can skip using temporary tables actually. But the problem is they are dropped at connection exit, so you can have other solutions for it instead of using temporary tables.
Sure, you can use permanent tables, but if your application is built to use temporary tables, then there's a problem.
We are aware of the problem. We don't have a good solution in the Python right now. It's a tricky problem, so it's not easy to solve.
Okay, so maybe a last question, yeah?
Does any of this affect how execution time is recorded as binary logs?
The execution time is reported, if I recall correctly, when the transaction starts. So if you have a huge transaction, then the delay will be seen as longer, yes. Did that answer your question? Or?
Yes, so it incorporates the time that it takes for the acknowledgement to come back from the slave.
No, I'm not sure if you're talking about seconds behind master or if you're talking about semi-synchronous replication. Because you only get an acknowledgement if you use a semi-synchronous replication. And the acknowledgement then is the time then is how long time it from it sends it until it fetches it. That's the timeout time. And for seconds behind master, then if I recall correctly, it's the seconds behind master is the starting time of the transaction compared to the current time of the transaction, the current time on the slave, and then you have a delta also if the slave and master have different clocks. So that's how seconds behind master is calculated. Okay, we'll take one more question.
You mentioned about exporting data from MySQL to non-MySQL consumers. What kind of directions are you looking at in pursuing that?
Exporting data to?
As one of the future directions you'd mentioned, sort of replication to non-MySQL consumers. So I was wondering what thoughts you had on what direction you're going with that.
We want to have a general solution so that one can have different kind of replication methodology to do replication, and you should also be possible to replicate into other database systems or something like this. And this is the interfaces we are working on, but exactly how this will look, there's still a design discussions being done on this.